Hi guys, so we are officially starting chapter 2A. I feel like it's been a while since we learned something new, really. So here is something new for you to do. We are learning all about rational numbers, what those are, what they look like, how to use them in this chapter or in this section. By the end of the hour, you should be able to order positive and negative numbers. As you can see here, I put that's technically review. We've done that. Order fractions and decimals, also technically review, but skills you'll need today. Change rational numbers to decimals, change rational numbers to fractions, and then we'll also get a little start on ordering rational numbers. So let's recall, how do I order the following integers? Remember, integers are just like a number line. So if I had a number line up here, 0 would be in the middle, and then I would have -1 next to it on the left, +1 on the right, +2, and then over here on the left, -2. So our numbers kind of mirror each other from 0. If I look at 0, when I go to the right, it's growing bigger. When I go to the left, it looks like it's also growing bigger. 1, 2, 3, 4, 5, but they're negative. So really, they're growing smaller. So our really big negative numbers are actually really small negative numbers. So our smallest number here is -12. It might look like it's our biggest number, but because it has the negative there, it's actually a lot smaller. We're done with that. Then we have -9 and -2. Those are all of our negative numbers. So now I just have positive. Which one's smaller? 3, and then 8. So again, that's a review, how to order negative numbers from least to greatest. Another thing that is review is how to order fractions and decimals from least to greatest. Well, it's way easier if they're either all fractions or all decimals. And if they're fractions, then you need to have common denominators. So personally, I order decimals. I change them all to decimals and I order them that way. So here, 1/2, I know that off the top of my head that's 0.5. So I don't really need to do any long math with that one. 1/2 is really 0.5. 4/5, I might need to do a little bit of long division here. So really that means 4 divided by 5. 5 does not go into the number 4. So I add a decimal and a 0. 5 goes into 40 8 times, making sure I add my decimal and my answer as well, which is 0, or 0 leftovers. So that really means that 4/5 is 0.8. Now that they're all they're all decimals, it's a lot easier for me to order. So my smallest number here, you might think, oh, it's a 5, 0.5, that's smallest. Well, 0.5 is really like 50 cents. One thing I like to do is whenever I'm ordering decimals, I like to write them on top of each other. Okay, so 9.3, 0.8, 0.09, and 0.5. And what I like to do is I first like to look at my whole numbers. Which one has the biggest whole number? Well, the 9. So that means that's my greatest number, 9.3. Then I like to look at the tenths column. So I've got some ties here, or not some ties. I've got 3, 8, 0, and 5. Well, the 3 was already used. 9.3 was already used, so I don't even need to look at that. So now I'm on to 8, 0, and 5. Well, the next biggest one is 8. So 0.8. But I still got some left over there that aren't tied. So next I can move on to my 0.5. And last but not least, my 0.09. So when the numbers are stacked on top of each other like that, it's a lot easier to see which one is the biggest, which one is the next biggest, and so on and so forth. Okay, so again, when I got to this column right here that I'm circling now in green, I really had to break up which one was the next biggest and then the next. When they were tied, like they were in the red column over there, then I had to move those ties onto the next column, onto the next place value. Again, this is review. You did learn this last year. We're going to move on to some key vocab for today. So here's some new things that you should take notes on, it says. You should write down. A terminating decimal. This is a term we learned last year. A terminating decimal is a decimal that ends 0.5, 0.86, 0.72, 0.8754, done. There's no more numbers after that. So if I do long division to get my decimal, it's one that ends up getting 0 at the end. I don't keep getting a number over and over again. It ends. There's no pattern. It just ends. Whereas a repeating decimal, remember, means it repeats the 3 over and over again. 3, 3, 3, 3, 3, 3, 3, 3, 3. Or it could even repeat in a pattern, 0.16, 16, 16, 16, 16. And no matter how long you do your long division, you're going to keep getting that number up at the top. That's a repeating decimal. A rational number is a fraction or a decimal that's positive or negative. So if I say 5/8, that's a rational number. If I say negative 5/8, that's a rational number. 0.82, rational number. Negative 0.82, rational number. Now, 8.2 is not an integer because integers have to be whole numbers. So integers we learned in chapter 1, negative 10, positive 10, negative 8, positive 8, negative 772. That's an integer. But negatives aren't whole numbers. Whole numbers are only positive whole numbers. So a 5, 7, a billion, trillion, those are whole numbers, but they have to be positive. So in this chart down here, you can see we start at whole numbers. Those are all positive numbers that are not fractions and not decimals. They're perfectly whole numbers. Then we move on to integers, and that's where we add in negative whole numbers. And then on the outer box, the square on the outer edge, rational numbers, is positive whole numbers, integers, which are whole numbers but negative, and we throw in decimals and fractions. Those are rational numbers. Okay, so now we're moving on. Take notes on how to make a fraction into a decimal. Rational numbers as well. So these are positive or negative fractions and decimals. Well, step number 1, you do exactly what we just did in our review. Numerator divided by denominator. This part's really tricky. If it's a negative in your question, it's a negative in your answer. If I said negative 1/2, that's the same as saying negative 0.5. But a negative 1/2 and a positive 1/2 aren't the same thing. So you've got to make sure that if your fraction was a negative, then the decimal form of the same number is also a negative. If your decimal was a negative, the fraction form is also a negative. So you bring that negative down to your answer. A lot of people tend to lose their negatives during this. You want to make sure you don't lose them. So here's our first example, negative 17/8. And we want to write it as a decimal. So negative 17/8 as a decimal. Remember that fraction bars here really just mean division. So 17 divided by 8. Eight does not go into 1, but it does go into 17 2 times, which is 16 and 1 left over. Since we're going to a decimal, we can't have any remainders. So what we do now is we add a decimal and a 0. If I added a decimal in my question, I have to also add a decimal in my answer. Now I can bring that 0 down and figure out how many times did 8 go into 10. 1 time with 2 leftovers. Again, I can't have remainders in a decimal answer, so I bring a 0 down. 8 fits into 20 2 times, which is 16 with 4 left over. Add a 0, bring it down. Ooh, it looks like we're getting to an end. 8 fits into 40 5 times, which is 40. And I have 0 left over. I ran out of room, but we got 0 as a remainder. So my answer then is 2.125. But we've got to make sure that if it was a negative in our question, it's a negative in our answer, which it looks like it was. So it was negative 17/8, which means it needs to be negative 2.125. So again, we did that long division here. We're going to go through another example as a group. So we have negative 4 and 5/8. What I personally do is I'm going to ignore the whole number for a second, and I'm just going to worry about my 5/8 here. To change 5/8 to a decimal, remember we do 5 divided by 8. 8 does not fit into 5, so I add a decimal and a 0. Remember, if I add a decimal in my question, or in the question, I have to add a decimal in my answer. 8 fits into 50 6 times, which is 48. So I have 2 left over. Then I add a 0 and I bring it down. 8 fits into 20 2 times, which is 16, with 4 left over. I add a 0, bring it down. 8 fits into 45 times, which is 40, with 0 left over. So now I have that digit 0.625. So 0.625. But that's not my answer for a couple of reasons. First, I've got this negative up here that I need to focus on. Second, I had a whole number out in front that I ignored. I can't ignore it forever. So the negative and the whole number need to pop out in front of my decimal. So really, I have negative 4.625 as my answer. So again, sometimes you got to do that long division. I dealt with my fraction, made it into a decimal, and brought my negative and whole number down. Okay, so you are going to try both of these questions in your notebook. So change both fractions to a decimal. Go ahead and try it now. Press pause on the video. All right, let's go ahead and look at these answers. So negative 3/8 turns into negative 0.375. Negative 6 3/10 turns into negative 6 3/10, just in decimal form. So as you can see in this first one, I made sure not to lose my negative out in front. It was in my fraction, so it's got to be in my decimal. In this one, I made sure not only not to lose my negative, but also my whole number here. You don't want to lose the whole number out in front. All right, now we're going to go the other way. We're going to take our decimal and make it a fraction. So remember, we place our decimal as the numerator, and whatever place value it is, that's our denominator. So the decimal digits over its place value. And I put big capital letters here to make sure that we simplify. Okay, so we've got to simplify in our answer. Then, just like before, if needed, bring the negative down. So if it was a negative decimal, it's also going to be a negative fraction. So we're not actually changing the number. We're just making it look different. Because saying I have half a dollar is the same as saying I have 50 cents. I didn't change my value. I just changed the way I said it. So let's go ahead and look at an example. We have negative 0.26. So really, this says negative 0 and 26 hundredths. The 6 is in my hundredths place. So this fraction is going to be over 100. So 26 over 100. It was a negative, so I've got to make sure I bring that negative down with me. So negative 26 over 100. But we also have to simplify if we can, which 26 and 100 are both even numbers. So I can divide both of these guys by 2. That's going to end up giving me 13 over 50. But this is like the most common mistake I see with this. It's not 13/50ths. It's negative 13/50ths. Make sure you don't lose that negative along the way. Okay, so if it was a negative to start with, it's still a negative in fraction form, in simplified fraction form as well. Don't lose that negative. So go ahead and you try this one in your notes, negative 5.8. Press pause on the video and try it on your own. All right, let's check the answer for this one. So negative 5.8 really says negative 5 8/10, which simplifies down to the real answer, negative 5 4/5. All right, so now we're going to move on to ordering them. So we know how to convert back and forth. Now we're going to order them from least to greatest. So first, you're going to convert all of your numbers to the same form. So either make them all fractions or make them all decimals, just like we did in the example up there where we reviewed. So personally, I'm going to continue to make all of mine decimals because if you make them all fractions, you have to have common denominators in order to order them, which just seems like extra work to me. So for me, I'd rather just make them all decimals, which is what I'm going to do in all of my examples. But if you'd like, you can make them fractions with common denominators and then order them, up to you. Then order them from least to greatest. And in the example we did earlier, that's where I wrote them all on top of each other and then went column by column. Biggest thing here, and some of us struggled with this in chapter 1 with our absolute value ordering. Make sure you rewrite the numbers in the original form. So if the original fraction was 1/2, but you changed it to 0.5 to order it, make sure in your answer you change it back to 1/2. So let's go ahead and look at an example here. So I've got all these digits going on. I need to change them. So they're either all fractions or all decimals. And like I said before, I'm going to change them all into decimals. So you might need to do some long division here multiple times, and that's okay. I'm just going to point out that I know that 3/2 is really 1.5. And I know that 1.5 is really 1.5. Same thing with 5/2. I know that 5/2 is really 2.5, negative, because it's negative in this case. And negative 2.5 is the same as negative 2.5. So I didn't actually have to do long division for this one because I knew those ones off the top of my head. If there's one like 1/4, well, you might know that 1/4 is 0.25, and that's okay if you have those memorized. Now, 6 2/3, I don't have that one memorized, so I'm going to need to do some math off to the side. So I'm going to take 2/3 and convert 2/3 into a decimal, and I do that by doing 2 divided by 3. Now I know that 3 does not fit into 2, so I add a decimal and a 0. 3 fits into 20, 3, 6, 9, 12, 18, 5 times, which is an 18. No, I'm sorry. That's 6 times. 6 times, which is 18, with 2 left over. So I add a 0 and I bring it down. 3 fits into 6 or into 26 times, which is 18. So I have 2 left over. So I'd add a 0 and bring it down, which is 6 times, add a 0, bring it down. I'm going to keep getting that. So really, 2/3 is 0.66666 repeating. But I've got to remember that I have -6 in front of that 0.6666 repeating, and that's okay. So really, this is -6, 0.666 repeating and repeating. I can put the line above it to help me see. So now I'm ready to order them. I'm looking for my smallest number, which really looks like my biggest negative. But because we're going backwards, it's actually the smallest. So my negatives are -6.6 repeating, -0.5, or -2.5. Well, -6 is the biggest there, even if there's stuff hanging off of it. But remember that I'm not going to write -6.6. I'm going to write its original number, -6 2/3. My next number is, I'm done with that one. I've got a -0.5 and a -2.5. Well, -2.5 is smaller. And remember, it wasn't -2.5, it was -5/2. Now I've got -0.5. Now I can move on to my positive 1.6 or 1.5. Well, 1.5 is smaller, so that's really 3/2. Which is going to give us our final and biggest number there, 1.6. So there's our final order. As you can see, remember I wrote it as the original form. So even though I changed 3/2 to 1.5 to help me, when I wrote it in my answer, I kept it as 3/2. So in these problems, it's kind of a lot of problems all in one. As you can see here, I had to change that to a fraction, that's a problem. I had to change that to a decimal, that's a problem. I had to change that to a decimal, another problem. And then I had to order them. So ordering fractions and decimals really are multiple problems all in one. Let's go ahead and you try this one in your notebook. So again, you're trying this one. Press pause on the video and try it now. All right, let's check that answer. So in green here, I ordered them all as decimals. And then in red, I rewrote them back into fraction form, or I kept it in decimal form depending on what I started with. Let's go ahead and you try another one. Press pause on the video and try it in your notebook now. All right, here's the answer for that guy. Again, I ordered my decimals first, and then I rewrote them back in their fraction form if I needed to. Really, after today, there's two things that you really should feel good about. Taking a fraction and writing it as a decimal, and taking a decimal and writing it as a fraction. Keeping the negative if there is one. Don't add a negative if there's not. So go ahead and you try these two in your notebook to really see how are you doing after day 1 of 2.1. And here are the answers for those. So hopefully after today you can convert between fractions and decimals, whether they're positive or they're negative.